tree traversal. What do we mean by tree traversal? Once we have a tree, it consists of vertices, internal vertices and leaves, right? So the question is, we want to visit all the vertices in the tree. You can visit them randomly, that's fine, but that might be very costly. There are algorithms that we follow to visit the vertices. Each one of these algorithms has some advantages according to the applications that we are using the trees for. So okay, first let's see what we have here. Ordered trees are often used to store information. So storing information in a tree, in the vertices of the tree, once you need to retrieve information or some kind of information, you may need to apply one of the algorithms that we will use to visit each vertex in this tree. So as it is written here, so we need a procedure for visiting each vertex of an ordered rooted tree to access data, and we need algorithm for visiting all vertices. Okay, so we will see that today. Let's start with universal address systems, where we address or give labels to the vertices in the tree. So the root of the tree will be given a 0 because we might consider this as level 0, like a ground level. And then the level after that will give it integers, as we see here, 1, 2, 3, 4, and 5, so on. And the level that comes after, the subtrees that has 1 as label of its root will take these values 1.1, 1.2, 1.3. We go to 2 has no leaves or no subtrees. 3, we will go to 3.1, 3.2. 4 has one leaf only. 4.1, 5.1, 5.2, and 5.3. So this is level 2. We used points in here, and this is what it meant here. For each vertex V at level N with label A, so it is assuming that the vertex, so I want to make this statement here clear. We have a label A for some vertex, and then we have children of that vertex. Then we will call this A dot 1 because this is labeled A. And this is A dot 2 all the way A dot 3. We assume there are some vertices, and this is ends at A dot KV, where we mean by KV the number of children of the vertex labeled with A of this vertex. So if we use this labeling in general in the tree, then we produce the tree as we see here. If we keep going, now we have here 3.1 for instance, and then the children for 3.1 will take 3.1.1, 3.1.2, 3.1.3. Now in here we have 3.1.2, and then the children's will be 3.1.2.1, 3.1.2.2, 3.1.2.3, and 3.1.2.4. I think you see the idea now, and this 5.1 has only one child, which is 5.1.1. So okay, so this is called universal address system of an ordered rooted tree. So the idea here, as you see, we are giving labels two vertices, and these labels will carry some information about the vertices, mainly about where the level of the vertex, or in which level the vertex lives. Okay, now let's go to the algorithm I talked about. The idea here, we want to visit all the vertices of the tree, and we will learn 3 algorithms that help us to do so. The first algorithm, which is called pre-order traversal, and it is described simply by visit the root. Okay, so first you visit the root of a tree, and then visit subtrees left to right. So okay, so once we visit a vertex, we will take it off the tree and put it in the list below. And now the list you see here is the order, and here I may say the order of the vertices that we are gonna visit. As you see, A is ordered at the beginning, which means we will visit A, and then B, and then E, and then G, and so on. But we want to know how this order in here came out according to the pre-order traversal. It says visit the root, take it outside the tree, and then visit the subtrees. Start subtrees at the left, and then go to the subtrees at the right. Okay, so in here we will start with the root A, because it says visit the root. Okay, once we take it, we will go to the subtree, left subtree of A. Once we go there, then we are at a new tree in which we will take the vertex, the root, sorry, and then we go to the left subtree of it. Again, we will be at a new tree, another tree, in which we will take the root and then visit the left subtree of it, and so on. So let me make it clear in here. Now we will take A, okay? So this will be taken as number 1. So this is, I will label it 1, because that means I will take it first, okay? And then I will go to the left subtree of A. So I will go here. This is the left subtree of A. Once I am done with that, then I go to the other subtree, but going from left to right. The other subtree is this second subtree, and then the third subtree will be this. So now each one of these subtree will be treated in the way described here. Take the root and go to the left subtree, and then go from left subtree to right subtree, so on. Okay, so let me erase things from here to make things clear. So I start at A and go to the left subtree. Okay, so I got this left subtree in here. So it has root B. The algorithm here says take that root, so start with the root. So I will take B. I already took A, which is number 1. B, I will give it number 2. Now once I take B, the root, I go to the left subtree. What is the left subtree whose root is B? It is this subtree. Okay, so I will go inside the subtree. Now it says take the root, and the root is E. So this is the number 3 vertex that I will take. Once I take the root, I go to the left subtree of that root, which is this thing here. And it has J only, a leaf. I will take J. Then I am done with the left subtree whose root is E. Then I will go to the right subtree, from left to right. To the right subtree whose root is E. So I go here. Okay? What I do? Take the root. So this will be number 4. Take the root of this subtree. And then when I take the root, I go to the left tree it has, which is this one. It is a leaf, so I will take n. So n will be number 5. And then go to the right, subtrees from left to right. Then this is the subtree, the next one to the right. So I will take this vertex, will be number 6. And then this vertex will be number 7. Once I am done, I go back to the vertices that I did not take, which is at root B. I went to the left subtree of B. Now I will want to go to the right subtree of B, which is only this leaf, F. So F will be number 8. Okay. Now I go back to A, and I'm finished with the left subtree of A. Then I take the one next, or left from right, which is only this leaf. So I will take C, and this will be number 9. I am done with this subtree. It is only one leaf. Then I move to the right to work with the right subtree of A, the most right subtree of A, which is this. Okay. What I do, I take the root. So this will be number 10. Once I take the root, I go to the left subtree, which is this. This is the left subtree of the root D. Once I get to that tree, I take the root right away. So this is number 11. After I take the root, I go left subtree, which is a leaf, which is only L. So this is number 12. I go back to that root and go to the right subtree, which is M. So this is number 13. Is not necessarily a right. Here we have 2 subtrees, left and right. But if we have 3, then we keep going in order, left to right, as we have done here. Okay. So we are done. Go to G. Back to D. We have taken the left subtree, then we take the subtree that comes after from left to right. So we will take this subtree whose root is D. So this will be number 14. And then we keep going to the right. And this is number 15. Okay. Did I miss any number? 1, 2, 3. So let's see what we got the numbers here. We got 1 for A, 2 for B, 3 for E, J. Then we visited J. Oh, I missed a number. Yes, I can see. Sorry for that. I missed a number. I missed counting. This shall be 5. And I need to fix everything after that. This is number 6. This is number 7. This is number 8. And so we increase by 1 to fix our mistake, by mistake. 10. So this will be 10. This will be 11. Sorry for that. And this will be 12. And this will be 13. And replace that with 14. And this will be 15. And this will be 16. Okay. So if you go back, number 5 was K. Yes. Number 6 was N. 7 O. And P was 8. And so on. And this is 9, 10, 11, 12, 13, 14, 15, and 16. Okay. Okay. So the idea was visit the root and go to the left subtree. And to go to trees, visit subtrees from left to right. So take the root, go to the left, you find subtree, take the root, and keep doing so. To go to the left, you find another subtree, take the root, and start from left to right, so on. Okay, so I hope this is clear. So the pre-order, and we need to remember these names. This is the pre-order traversal. Visit root, and then visit subtrees from left to right. Okay. Let's go to what is so-called post-order traversal. Post-order traversal. It says visit subtrees from left to right. Once you are done with subtrees, go and take the root. Okay, let's see that. So this is the root here, A, but we will not take it. We will go to visit the subtrees whose root is A. So we will visit this subtree, okay, and then visit this subtree, and then visit this subtree, okay, from left to right. Now let's go to the subtree to the left. Okay, now it has a root B. We will not take it because we want to visit subtrees first before we take the root. So we go to the left subtree of B, which is this one, and then once we are done, we go to the right subtree of B, right? Okay, now notice here we are at the root where we are at a subtree where E is the root. We will leave it, will not take it, and we will go to its left subtree. It is J, so it is a leaf, so we will take it. So we will take J, so this is number 1. Okay, now we go back to the root and take the right subtree, and this is the right subtree. Okay, but we will not take J because we will take the subtrees first from left to right. So going to take the left subtree, which is N now, it is a leaf, so this is number 2. Now going from subtrees from left to right, so we have leaves in here, so this is 3 and this is 4, so we'll take them. Now we have taken all the subtrees of the root K. Then we go back and take K, the root after that. So this will be number 5. And now notice we have taken all the vertices in the subtrees of the subtree whose root is E. We have taken all the vertices there, and then now we will take E. This is number 6. I will not take B now because I did not take the vertices in its its subtrees. So I will go and visit the right subtree of B. It is a leaf. Then I take F. So I got this is number 7. And now I have visited all the vertices in all the subtrees that are rooted at B. Then I go back and then take B. So this is number 8. Okay, now going back to A, but I will not take A because I must take all vertices in the subtrees that are rooted back to A. So I will visit the other subtree of A. I am finished with the first subtree of A, this one. I am finished with the first subtree of A. So I will go to the one next to the right of the one I finished, which is only this leaf. So I will take it, and I will take C, and it will be number 9. I will not take A. I'll go back to A, but I will not take A because I will move one more movement to the right subtree. So I will work with this subtree now here. It has the root D, but I will not take D. I will go to its left subtree. It is in here. And it is rooted at G, and I will not take G because I want to go to its left subtree, which is this one. So I choose L. This is 10. and then I go to the right subtree of that root of G, then I get M. Now I have visited all subtrees who are rooted back to G, then I will take G, this root. Now I will take it. I will not take D because I need to visit this subtree of D and has a leaf H. I will take it, and also this subtree moving from left to right, and this will be number 14. Now I have visited all the vertices of the subtrees which rooted back to D, then I go back and take D now, and this is number 15. Now I have taken all the vertices in the tree whose root is A, then I go and take A, this is number 16. And if you follow these numbers, we started with 1 which was J, 2 was N, 3 O, and 4, 5, 6, and so on. Okay, so this is the post-order traversal. It says visit the subtrees from left to right and then go take the root. But the pre-order, it says take the root and then visit subtrees from left to right. Okay? Now the third algorithm for visiting trees is called in-order traversal. What does it say? Visit the leftmost subtree. Once you are done, go take the root and then go to the other subtrees from left to right. Okay? So we will not taking the root at the beginning here. The pre-order requires you to take the root and then move subtrees from left to right. The post-order requires you to move subtrees from left to right and then after that take the root. The in-order, it requires you to go to the left subtree. When you are done, go take the root and then go to the right subtrees in order from left to right. Okay? So let's see. Once we start at A, we will not take it because we want to go to the leftmost subtree of A, which is this subtree. Okay? Now we have a subtree which is rooted at B, but we will not take B because we want to visit its left subtree first. And this is the left subtree of B. Okay? It is rooted at E. We will not take E unless we go to its leftmost subgroup, which consists only of G, a leaf. So we will take G. So this is number 1. So we have finished the leftmost subtree which is rooted at E, root E. Then we go to E and take it because this is what it says, visit the root. After you visit the leftmost subtree, visit the root. So this will be 2. Once we are done with the root, then we go down to the right subtrees. Okay? So once we take E, we go to its right subtree and we find it to be this. We will not take K unless we go to its leftmost subtree, which is N. So we will take N first, so this will be 3. And then we go to take the root, this will be 4. Okay? And then we move left to right, this will be 5, and this will be 6. Okay? Now we are done with the leftmost subtree which is rooted at B. Then we will take B and this will be number 7. And then we go to its right subtrees, which is this, and this will be number 8. Now we take A and this will be 9. Why? Because we have visited all vertices in the leftmost subtree of the root A. Then we go back and take the root again before we visit the other subtrees. Okay, so now we go from the left to right. This will be 11, and then we go to the more right subgroup of subtree of A, which is rooted at D, but we will not take D because we want to go to the leftmost subtree of D, which is this, and we will not take G unless we go to the leftmost subtree of it, which is L. So this is number 12. Now we go take G, 13, and this will be 14, and we will take D for the same reason. This will be 14, 15. Okay, so did I do mistaken count? Where is 10? So sorry. This is supposed to be 10, and this is supposed to be 11, and this is supposed to be 12, and this is supposed to be 13. Okay, and now this will be 14, and keep moving as before. This will be 15, and this will be 16. Oops. Okay, so if we match the numbers, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Doing fine. They are matching, right? As the one I did them there. 14, yes, good. And 16. Okay, so this is the in order traversal. So good. You need to practice in that so that you distinguish between these three algorithms. Okay? Now, how are we gonna use these algorithms? Let's see. Okay, so you can guess from these trees, what do we mean? We have transformed this expression into trees. So this will say at the beginning, we will add x and y. Once we do so, we will divide it by what? The addition of x and 3. Okay, so we get that. In here it says we will divide y by x. Once we are done, we will add that to x. Okay, maybe I will draw this. Okay, so y over x plus x. Once we are done, we will add all that to 3. So y over x plus x, add all that to 3. Okay, let's see what we get here. We will add x plus 3. Once we are done, we will divide y over x plus 3. And then once we are done, we will add x to what we got. So x plus 3 divide y over x plus 3 and plus x. So we get that. So you have an idea now how we transformed expressions into trees. Okay? Let's see how this related to the algorithms we have just seen. Okay. Now you can guess, as we have done a little while ago, that this expression is represented by this tree, right? It is x plus y. This means this in here means a power exponent. Okay. So x plus y. Take x plus y. Once you are done, raise it to power 2, right? And then add all this to what? To first x minus 4 and divide that by 3 and then add everything in here to what we have already got from the leftmost subtree, and then we got what is above there. Okay, so let me clean all that and relates what you want here to the prefix form. What do we mean by prefix form? Simply visit the vertices of this tree in here, of this expression, using the pre-order traversal. Remember that the pre-order traversal says take the root and then go to the left subtree and then visit the subtrees from left to right. Again, take the root and then visit the root and then visit subtrees from left to right. So if we apply that, then we will take the root and visit the subtree in there, which is this subtree. So in here we took the root, this is plus. Now this subtree take the root and list it here, it is here, and go to its left subtree, take the root, it is here, and go to its left subtree, which is x, so we take x, and then right subtree we take y, okay, y. We go back to this root in here and take the subtree, right subtree, and then we go back to this root and apply the same thing again. So we will take this, this, and that, and then we'll take the 4, and then we will take the 3, and then we get all this expression. Okay? And then we got all this expression. So this will be called a prefix form. Okay? Now, if you are asked a question like this, what is the ordered rooted tree? What is the prefix form of this expression? What you do, produce a tree for it. Okay? Once you got a tree, visit the vertices using the pre-order traversal, and then put them in this order. The one you visit, put it at the left as we have seen. Okay? Now, what does that mean for us? We will see. But let me clean all these things, because we are asked also to find the postfix form of this expression. Okay? So let's find the postfix form of this expression. So we got a tree, and we will visit vertices according to postfix form. Remember, the post order traversal says visit trees from left to right and then take the root. Visit trees from left to right and then visit the root. So we will not take this root. Go to the left subtree in here, the left subtree, and then go to the left subtree again, and then go to the left subtree again. So we will have x. Let me write it in black. So first one we choose is x, and then it says visit from subtrees from left to right, and then we take y. Now take the vertex, so we'll have plus. Now visit this right subtree, we will take 2. Now take the root, sorry I said the vertex, so we will have that. And then we'll not take plus, which is the root in here. We will go to the right, okay, subtree, and take the left of it, and then keep taking the left. So we will have in here x, take the right, 4, take the root, which is minus, and then take the right, which is 3, and then take the root, which is the division, and then we go back to the original root in here and take the plus. So this gives the postfix form. Okay. Now, how can we obtain this original expression directly from prefix form or from postfix form? How can we obtain them? And here it says, in a prefix form of an expression, a binary operator precedes its two operands. When we say a binary operator, which is plus or minus or division or exponent, and we know that each such operator will has two sides at two things at the side, like x or variable or constant. Like if I say 3 plus 5, those are the operands, the 3 and 5, and the plus is the operator, the binary operator. X times 7, those are called the operands, and the operation in the middle is called binary operation. Okay, so in here it says the binary operation precedes its two operands. Okay, so if I find the two operands and then a binary operation that comes before them, then these two operands will be operated according to this binary operation. Therefore, it says, I will explain what I'm saying here. Hence, evaluate an expression in a prefix form by working from right to left. Okay, we want to evaluate this prefix form here and reduce this expression. Now it says take from right to left. So now I will look for a binary operation. It is here in x. Okay, it is here the minus. So I will take the two operands that comes after it. Okay, so what will happen here, I need a space, so I will copy this here. It is plus and exponent plus x y 2 divide minus x 4 3. So what I said here, we have an operation in here, this minus, and then what comes after it is x and 4. So we will have x minus 4. Okay, and we will keep 3 here waiting, and we get everything down in order, and then we will keep going to see what happened. Now I have this binary operation and this operand and this operand. So all that together will be x minus 4 over 3. And then I will take 2 down here, and the y and x and plus and exponent and plus. Now I look for operand. What do I have here? Operation, sorry, it is plus. So I will take all that, and this is x plus y, and the 2 here will comes down, and also this one here, and now this operations are still waiting. Now if I notice here, these two operands, this and this one, comes after this operation, and so I will have x plus y to power 2. Okay, and this plus comes down as it is, and this comes down as it is. Now I have two operands, this one and this one, and they come after the plus, so that means we will add them. So we will have x plus y to power 2, and then plus x minus 4 over 3, and I got the expression back, this expression here. Okay, now it is okay, what I want to say here, that this is the postfix form And the question also was how to transform this form back to the given expression. Okay? And we will come back to it. Let us see. Actually, let me go down a little and then we come back to it right away. Why do I need to go down a little? Because of this note, which says in a postfix form of an expression, a binary operation follows its two operands. And if you think why this is happening, because if we go back to the tree above, you will find the binary operations are roots for subtrees. And when we used post order, we postponed the roots till after we take the subtrees or the leaves, which are the operands. So we have the operands first visited and then the roots, which is the operation. While what we have already seen, let me go back to it, in the prefix form, it says the binary operator precedes the operand. This is why this is true, because in the pre-order traversal, we took the root and then we visited the subtree. And you see in such a tree, the roots are labeled with the operations, the binary operation. So we take the binary operation and then we take the leaves that are the operand. So let's go back to this note in here. It says, as I explained, in the postfix, the binary operators comes after the operands. So to evaluate expression in postfix form, work from left to right, because we are taking operands and then binary operations. So work from the left to right. And so if I ask you to go back to this prefix form and transform it to the original expression. So what we do, I will do it quick here. We will take from left to right, so this y and x and y, and then the plus, that means x plus y. And then take this down as they are. This is division. Now I have this operand and this operand and this operation. So that will give me x plus y to power 2, and then take this down as they are, x 4 minus 3 division plus. Now we have these two, we have this operation and these two operands, so we will have x minus 4, and then take these down as they are, and also take this, copy it down here to power 2. And now notice we have this operand and this operand and this operation, which is division. So that will give x minus 4 over 3, and in here we get x plus y to power 2, and this operation goes down here. And now what's happening in here? We are having this operand and this operand and this operation. So what we have is, I need some space in here, is this operand plus the other one. So it is x plus y, sorry for that, to power 2 plus, so this plus is the one here. So plus that x minus 4 over 3. Yeah. Okay. Now what we do here, it is just an expression of numbers, and it says that it is given in a prefix expression, so it wants its value. And remember, in the prefix expression we start from right to left. Okay, let's see, from right to left. So the first operation is this, and the ones comes after it is 2 and 3, so we will evaluate that. And here we go. So 2 to power 3, so we get 8. So we replace all that with 8 in here, and the remaining parts still stay as they are. Now we have this operand and this operand, and it is preceded by division, so that means we will divide them, and then we get 2, and now all that will be replaced by 2, and the remaining parts will go down as they are. And then we proceed. Now we will look for where is the operation. This is star, okay, and it is followed by 2 and 3, which means 2 star 3, which gives 6. So we have 6 in here, and this 5, this 2, and this minus, and this plus. Now I have this operation, and it's followed by 6 and 5. That means 6 minus 5, which is 1. So I get this, and now this operation, and I have 2 operands, 1 and 2, preceded by plus. So I add them, I get 3. So we go to the right. Once it is a prefix expression, we go to the right, and then we will walk from right to left to find an binary operation. We stop in there, and take the operands that comes after it, or coming from the right, I may say, before it. Okay, and remember why this is happening, because in a prefix order we visited roots before subtrees. Okay, now another example. What is the value of the postfix expression? So then here it says it is a postfix expression. It says go from left to right. So if we go from left to right, this is the very first operation we see, and then we take the 2 summands of it. In here we are working with binary trees, huh? Okay, so that means 2 times 3, which is 6. So this will be replaced by 6, and then after that there is a minus, which is in here. So we have 6 has already appeared, and 7 is given. So we have 7 minus 6, so we get 1, and this one in here. And now I have exponent, so it is 1 to power 4, which is 1. So this goes here. So I have 1, 9, 3, and then division. So I will take the 9 and the 3, the 2 operands that comes before the operation, and do the computation. 9 divided by 3, which is 3, and this one comes here, and this comes here. Now it is 1 plus 3, and this gives 4, and then we are done. Okay, and that's it for this lecture.